Sample determination is essential in any study or research so that the researcher correctly describe the details and information they want in a population, and further verify the veracity and applicability of the results of the study or research. Please take note of this. Larger sample size gives more reliable results with greater precision and power, but they also cost more time and money. That's why we need a specific way to determine a smaller size but can determine the characteristic of the population. And one of this is the Slovin's formula. For this video, I will discuss Slovin's formula for senior high school statistics and probability. Before I proceed, please subscribe my math YouTube channel. Now let's continue for this definition. Slovin's formula is the most common formula in determining the sufficient sample size to represent the population in any research or study. Its formula, lowercase n equals uppercase n over 1 plus uppercase NE squared, where lowercase n represents the sample size, uppercase n represents the population size, and lowercase e for the desired margin of error, Fs the allowance for non-precision because of the use of sample instead of population. Let us illustrate further Slovin's formula by answering some problems related in determining the sample size. Number 1, for instance in your research, if the population is 2,400 and the margin of error you allow is 3%, what is the sufficient sample size? To determine or solve for the suggested or sufficient sample size for the population of 2,400, first read and understand the problem and write the given. Continue. Lowercase n representing the sample size is unknown. Uppercase n represent the population is 2,400. Lowercase e represents the margin of error is 3% or 0.03. We will use that given or information to solve for the sample size using the formula lowercase n equals uppercase n over 1 plus uppercase NE squared. Let us now start solving. Represent the value of uppercase n, which is 2,400, to both the numerator and denominator of the formula. Substitute also 0.03 to the lowercase e on the formula. After substitution, the general equation to solve for the sample size is lowercase n equals 2,400 over 1 plus 2,400 quantity 0.03 squared. Simplify first the exponents, so we have 0.03 squared equals 0.0009. Next, multiply 2,400 and 0.0009. Its product is 2.16. Simplify the denominator. 1 plus 216 equals 3.16. Simplify further the whole expression by dividing 2,400 divided by 3.16, and the quotient is 758.49. Since we are talking with person or any population, we don't have 0.49 value. So we need to round up 758.49 to 759. Remember, in any decimal we have, we will round up the value. No round down. By that, we can now say that the suggested or sufficient sample size for 2,400 is 759. Problem number 2. A student wants to conduct a research for his subject requirement. If the school has a total number of students of 1,836, solve for the sample size he needs using the 95% confidence level. For our given, again, lowercase n or the sample size is unknown. the uppercase N or the population is 1,836, our margin of error is represented by 95% confidence level. 100 minus 95 equals 5%, so therefore 5% equals 0.05. Substitute the givens on the formula. Substitute 1,836 to uppercase N to both of numerator and denominator and 0.05 to lowercase a. Again, after substituting the values on the formula, our general equation to solve for the sample size is lowercase n equals 1,836 over 1 plus 1,836 times 0.05 squared. Again, first to simplify is the exponent. So we have 0.05 squared equals 0.0025. Multiply 1,836 and 0.0025. Its product is 4.59. Next, simplify the denominator. 1 plus 4.59 equals 5.59. Simplify further. 1,836 divided by 5.59 equals 328.44, which will be round up to 329. Therefore, the suggested or sufficient sample size for this problem is 329.
Ang galing mo pala dyan ah. Hindi ko alam.
Next problem, number 3. Compute the sufficient sample size of a target population of senior high school students consisting of 144 grade 11 and 172 grade 12 students with 5% error of tolerance. For this specific problem, we need to apply the stratified random sampling because we have two groups of students. We have grade 11 and grade 12 with different number of students. For our given, lowercase n or sample size is unknown. Uppercase n or the population is 144 for grade 11 and 172 for grade 12, and our margin of error is 5% or 0.05. Let's proceed by solving first the sample size for grade 11 students. Substitute 144 to uppercase n to both numerator and denominator of the formula, and also 0.05 to lowercase n on the same formula. Again, the general equation to solve for the sample size for the grade 11 students is lowercase n equals 144 over 1 plus 144 times the quantity of 0.05 squared. Solve first the exponent. 0.05 squared equals 0.0025. Multiply 144 and 0.0025. Its product is 0.36. Simplify further the denominator. 1 plus 0.36 equals 1.36. Then simplify further. 144 divided by 1.36 equals 105.88, which will be round off to 106. Therefore, the sample size for grade 11 is 106 students. And now, let us also proceed to determine the sample size for grade 12 students. First, as usual, substitute 172 to uppercase n of both the numerator and denominator of the formula and 0.05 to lowercase n of the formula. Again, same as the past example, 0.05 squared equals 0.0025. 172 times 0.0025 equals 0.43. Then simplify the denominator. 1.043 equals 1.43. Simplify further. Divide 172 and 1.43. Its quotient is 120.28, which will be again round up to 121. Therefore, the sample size for grade 12 students is 121. Since we have now the respective sample size for grade 11 and grade 12 students, to get the total sample size of all the senior high school students, we will use the formula n sub t equals n sub 11 plus n sub 12. Or in other words, we will add the sample size of grade 11 and grade 12 to get the total sample size of all the senior high school students. By substitution, the sample size for grade 11 is 106, the sample size for grade 12 is 121. By adding them, 106 plus 121 equals 227. Therefore, we can now say with 95% confidence level that the sample size are 106 and 121 for grades 11 and 12 respectively. And it has a total sample size of 227 students. Again, I hope I help you in determining the suggested, appropriate, and sufficient sample size in your research. For further videos like this, please do subscribe, like, and share.